Hi. After Sean's excellent talk earlier, I want to rewind a little bit and look at more foundational thing within software development and things we're doing in PHP. Sean foreshadowed this talk a little bit by mentioning how he injects different objects into other objects. And I want to look at how we do this, what dependency injection actually is, because it's fundamental. If you're going to do anything in the world of Solid, you have to understand dependency injection. You have to understand it really well. You have to intrinsically think about injecting objects into other objects. So I want to go through for the next 40 minutes or so what the fundamentals of dependency injection actually are. So let's start with a quote from a guy called Mark Seaman. Dependency injection enables loose coupling, and loose coupling makes code more maintainable. This is the key. Nothing else is more important in what you do as a developer than making your code maintainable. It's really expensive to write code. You are not cheap to hire. You are not cheap to spend your time writing software. It needs to last more than 5 minutes. It needs to survive the fact that the clients cannot make their mind up. To do that, you have to change it. Requirements will change. You have to be able to cope with this. To cope with this, you have to maintain your software. So when we talk about dependency injection, we are talking about something called coupling. Coupling is a key for maintenance. Specifically, loose coupling is key for maintenance. So what do I mean by coupling? Let's take an example. In the days before computers and email and text and Facebook and everything like that, we used to write on bits of paper and send them to other people. I know this is a weird concept, but here's 2 examples. On the right here, no, on the left here rather, I have a postcard. And on the right, I have a letter inside an envelope. The postcard is tightly coupled. What do I mean by tightly coupled? Anyone? That's right, the address and what I'm trying to write are both on the same physical piece of paper. It's got a pretty picture on the other side as well. It's very nice to receive a postcard. But if I write a postcard, I cannot send it to someone else unless I rewrite the message as well. Now you take the letter in the envelope, I've written my letter, I want to send it to someone else, I can photocopy my letter, and then I can put it in a different envelope. So I've separated who I'm sending it to from the actual writing of the letter. The 2 are loosely coupled. So that's what I'm talking about. So the benefits of coupling loosely is, as I say, maintainability. Any given class can be more clearly defined. It can do less work itself. That makes it more maintainable. Systems are more extensible. We can rearrange classes. We can put them together in different ways within our application. We can take a class that we wrote over here and reuse it over here. It's quite simple to do this. And we can test things more easily. So if you are into unit testing and test-driven development, you'll discover that you can test things in isolation if they are loosely coupled. This is quite beneficial. It gives you more security in the ability of your software to do what you think it does. Right, so the rest of this course, talk is going to have lots of code in it, so pay attention, lots of code on the screen. Here's a worked example of our letter. Really, really simple system with all written code that looks something like this. We have a class, it has a class letter, it has some paper, we instantiate our new writing paper, and we're done. Usage is a little bit low. We instantiate a letter, and then we can call the write method on the letter. And we've written a letter to someone with the writing paper. Hand up who's written code like this. Yes. The rest of you are lying. Everyone has written code like this. All software has positives and negatives. There are some positives to this code I've just written. It is very, very simple to use. I instantiate my letter, my paper has magically turned up, I call the write method, and I'm done. really, really simple. It's very easy to write. It's not very complex. This is definitely a positive of this type of coding. The negative is obviously that it is tightly coupled. This is bad. The writing paper is directly attached to our letter. We cannot change it. We can't test letter without testing the writing paper. It's impossible. The two are very tightly coupled. This is not so good. So you have some obvious questions. The clients come along and said that they now want a different size piece of paper. Or they don't want writing paper anymore, they want a different type of paper. How are you going to make these changes? How are you going to add this flexibility to your software? So let's start with the most obvious way that you would do it. The way I would approach this initially is I will invent a parameter on my constructor, $size. So now, class letter takes the size is passed through to the writing paper, and when I instantiate my letter, I can pass through that I want A4 paper. Yay, we have solved the client's problem. Aren't we cool? All right, we've all done this as well, by the way. You don't need to put your hands up. Everyone has done this. What's the downsides of having done this? Anyone see any obvious flaws? The letter knows about the size of the paper. Yes. Why should the letter care about the size of the paper? The letter cares about the size of the paper because it's the only way to get it to the constructor of the writing paper. So we've made complexity on our letter just because of our writing paper is there. So maybe not such a good idea. Maybe we can do better than that. So I've been involved in Zen Framework for an awful long while. I started with version 0.1 and have been doing it a long while. When version 1 came out, we had this really great idea that we called Zen Registry. So Zen Registry is a solution to this problem, and a lot of my code from the early Zen Framework 1 days looks remarkably similar to this model. So rather than directly instantiating the paper, I pull it from my registry. And then I've got my paper, and then I can place words, and I've written my letter. So, and the usage would look something like this. I set new airmail paper of size A4 into my registry, and then I can retrieve it in my letter and write my letter. So again, it's not too difficult to do. Now, Zen Registry is named after a pattern called the Registry pattern, which makes it really cool because it's a pattern. It's another way of saying global. But we can't say global anymore because globals are bad. But if we put in a registry, suddenly it's okay. Right. This is a global. All I've done here is introduced a global dependency. If I go back, what's coming out of dollar paper when I do Zen Registry get? I haven't got a clue. On this example, because this is a talk and we're doing an introduction, there are no lines of code here between Zen Registry set and instantiating my letter. In the real world, those are in two different classes and a junior developer has been near it. You have no idea what is sitting in paper. Zen Registry was really clever, we thought, when we introduced it. There's a reason it's not in Zen Framework 2. Let's just put it like that. So the solution is inject the dependency. This is the way that we should be developing our software. And by injection, I mean we pass a fully constructed piece of paper to our letter. Nice and simple. One thing I really like about dependency injection is it is trivial. It is really, really easy to understand. It's just that most of us don't do it all the time when we ought to be. So instantiation looks something like this. Letter equals new letter, new writing paper, size A4, and then I can write my letter. I'm 100% sure that my paper is the type I want it to be. I'm 100% sure of its size. All is well. Right, there's another name for this. It's called inversion of control. If you're going to Google for this stuff, the two terms are used interchangeably by most people. I mentioned earlier that software has positives and negatives. Can anyone think any negatives to dependency injection? Say again? Yes, it's got more complicated. I'm now writing more code. I now have to think about my paper. The positives significantly outweigh this. I can naturally configure my paper. I can change it, I can deal with my paper independently. That is a massive positive and considerably more important than the negative of complexity. We have changed the effort required to write this letter to the user of the letter. But it's software. There's always trade-offs. That's it, we're done. That's our dependency injection. I told you, it's really, really simple. Obviously, the nice guys from PHP Serbia wanted me to talk for a little bit longer than this, so I've got some more thoughts. So we're going to talk now about the types of injection. Because this is software, and we're software engineers, we're architects, we like to make things more complicated. So we have more words for things, we have more ways of doing things. So there are four common types of injection. We have constructor injection, which is what I've told you about so far. You pass fully constructed objects into the constructor of the object that requires that dependency. There's a concept of setter injection. You have a method called setPaper. Sorry, not setter injection. I've got this run the wrong way. A property injection, you have a property called $paper inside your letter. You make it public. You can now assign directly to it. Don't do that one, ever. Setter injection, you have a method called setPaper. You pass the constructed paper object into your letter via some sort of method. And lastly, this concept of interface injection, which is essentially the same thing as using setter injection, but you've wrapped it within some additional code. So interface injection, you have some sort of interface. Here we've got one called injectPaper, which has a method called injectPaper, because I'm not very imaginative. And then if my letter implements injectPaper, then I know that the injectPaper method exists, and I can do automatic collection of a paper and inject it into my container. Sorry, collect it into my letter from my container. A couple of things to note. Too many constructor parameters is a code smell. If you have an object that takes 10, 12, 15 constructor parameters, there's a really good sign that object is doing too much. You probably wouldn't be thinking about that. There's another concept called two-phase construction. Has anyone heard of two-phase construction? No, you've done. I'm sure I may age a little bit here, but it was really, really common when writing Windows applications in the late 90s and early 2000s. What you would do is you would instantiate a class, and then you would call init on it, and then you could use your class. Two-phase construction. You have to construct the class, and then you have to initialize it. In the PHP world, we would construct our class, and then we would call a whole load of setters on it, and then we can use it. That's two-phase construction. The object is unusable until you have initialized it. This is a bad thing. Going back to our junior developers, they instantiate their object, and they go and use it immediately. They have not initialized it, because they will forget. You rely on documentation to ensure that your object is valid. Do not do this. So as a rules of thumb, when you're talking about creating objects and dealing with objects and injecting other objects into your objects, limit the scope of your objects. It is much easier to write code that doesn't do much. It is much easier to write a class with a single responsibility. The net effect of that is that any given class will have less dependencies. That makes it easier. Depend on interfaces. Constructor injection is really important. It is the way you should create any given object. An object must be usable as soon as it has been created. Less damage is done that way. Depend on an interface. Do not depend on a concrete implementation of something as a dependency. It will make your life easier long term. So if we look at our letter again, let's introduce that envelope that we talked about earlier. So a little bit more complexity involved here. I have to instantiate my letter. I now need a configured piece of paper. I now need a configured envelope. This is getting a little bit boring. It gets a little bit tedious to have to think about creating my envelope, creating my paper. I just want to write a letter. I don't want to have to go and worry about my paper. It starts getting a little bit more problematic to bother writing and using this code. So although I have made cleaner code, I've made my letter more maintainable, I've made my envelope and my paper easier to use and compose in different ways. The actual usage of this code is now harder. We don't like harder. We don't do harder very well. Software developers, we go the easy way. If there's an easy way and there's a hard way, and the hard way is better, we will always pick the easy way. Every single time. So how do we make using this way of working easier? We introduce something called a dependency injection container, which does the work for us. It's the thing that worries about creating the object for us. Key thing about dependency injection container is that it is completely optional. You can practice dependency injection and never ever use a dependency injection container. The two are completely separate concepts. I would advise you to use dependency injection container because I think they're quite helpful. But don't confuse them and the complexities around dependency injection containers with the concept of dependency injection. The two are separate. So, dependency injection container, how would you write one? What do they look like? They look something like this. Again, this is not complicated code. We simply write a class that has a method called getLetter, say, which does the instantiation work and returns our configured letter. Anyone can write this code. You can get your junior developer to write this code. It's really not difficult. And you end up with usage that is simply 2 lines long. This usage is now very, very similar to the very first piece of usage that we had right at the very beginning, where we instantiated the letter and we used it. Here we are simply retrieving the letter from our container. The burden on using a letter has now gone down again. You're far more likely to want to write a letter. Of course, we're very hard-coded at this point. We have to have A4 paper with DL envelopes. This is probably not what we want. So you're going to have to introduce some sort of configuration to your container. And you're going to do something like this. Some sort of parameters can now be configured into your container, and then we can use them when we're instantiating our object. So when we pull the letter out of the container, we know which size we need for both our envelope and our paper. So again, we've now got the same abilities as we had before, but they are completely separate from worrying about using our letter. Usage now looks something like this. So again, not particularly complicated. Create a letter container, pass in the sizes we need. At some point later, we can retrieve the letter, and then we can write our letter to whoever. Nice and simple. Okay, we all okay with this? Good. The other common thing that we have with PHP development and software development in general is that we like to use the same object in different places without getting a different one. So database connection is a good example of this. We tend to only want one database connection. A logger is another good example. You tend to only want one logger instance running in your application, but you would like to be creating your logger in your central container system. So how do you do that? Concept of shared objects. Your logger needs to go into multiple different objects that come out of your container. If you were to code it yourself, you would probably code it something like this. You're going to create some sort of I shouldn't stand there. You're going to get some sort of protected property called shared in this case, and then when we try to retrieve our letter, If we've already got one in our shared property, we just return it. If we don't, then we'll instantiate our letter like we did before, assign it into the shared property and return the shared property. Anytime I need a letter, I'm going to get the same one out again. That's quite a handy ability, because now that dependency can be used in other objects. So that's the fundamentals of dependency injection containers. Again, they are not especially complicated pieces of code. They're not particularly complicated concepts. So here we have a dependency injection container fundamentally creates an object on demand. That is all it does. You need an object, a container will give you one. It manages the construction of the dependencies of that object for you, so you don't have to deal with them at usage. It worries about separation of your configuration of those objects from the construction of those objects. And obviously, as I've seen, we can create shared objects that are used as dependencies for other objects. Although I said that code wasn't particularly difficult to write, nobody likes writing code for the sake of writing code. We actually like solving problems. That's why most of us are here, is because we like to see a solved problem. We like to solve interesting problems. Dependency injection containers are a solved problem. They are not very interesting. You're not going to want to write your own container. Do not write your own dependency injection container. Feel free to write one to learn how they work. Do not write one yourself. There are plenty out there already. Use one of these. These are in alphabetical order, so I'm not showing any bias. So Aura DI is okay. There's one from the League of Extraordinary PHP packages called Container. Dice, Illuminate is part of Laravel. Fabien Pantessier has created two. He's created Pimple, which is a nice standalone one, and he's created one as part of Symfony called Container. You can tell from this that PHP developers are not very imaginative with naming. And obviously Zen Framework has got two as well. We've got one called ZenDI and we've got one called Service Manager. As a rule, if you're using one of these full stack frameworks, use the container that comes with it. You may as well. All the examples will be in that format, so that's the one to be using. I don't tend to use full stack frameworks all the time. Now that I'm a consultant, I will tend to fit my solutions to the problem the client has. So I find myself using standalone DIs and DICs a lot more. And one I want to talk about is Pimple. Pimple is the world's most simple dependency injection container. If you want to learn how DICs work, this isn't a bad one to look at. There is 170-ish, 179 lines of code. You can read it in an hour and a half. You can understand it in 2.5 hours. That's quite powerful. If you want to understand how a well-written DI container could work, very simple one, then Pimple is a good one to study. I would recommend it. It's an entirely manual DI system, and it works like this. You instantiate your Pimple object, and we call it $container, because again, we're not very imaginative in our naming. Pimple uses array access as its mechanism, so I assign to letter a closure. I assume we're all reasonably comfortable with closures by now. They've been around in the language for a while. It's worth learning them. So the closure that you assign to a given key, in this case letter, will be called by Pimple itself when it needs a letter. When it calls this closure, it will pass through an instance of itself. I've called it $C. It's an instance of the container. This is really important because you need to get your dependencies for this object from the container itself. So in this example, I instantiate paper, I instantiate my envelope, and instantiate my letter and return it. So this code here is exactly the same code as we had in our own standalone container, which was exactly the same code as when we looked at how do you use this code in the first place. So very, very simple code just put inside the Pimple container. Usage looks exactly the same. Nothing has changed, except we're now using array access rather than a get method. So I say, because Pimple passes an instance of itself into the closure, you can separate out your dependencies into separate keys. So I can have a container for paper, a key for paper and a key for envelope that instantiate just paper and just envelopes. And then, when it comes to instantiating my letter, I can retrieve the paper and the envelope from my container. So following back to that principle of doing the least amount of code in any one place, that also stands true inside your dependency injection container. Any given item should only instantiate one thing, the thing you are trying to retrieve. If you need to instantiate two things within a closure that's attached to a container, you probably want to look at extracting one of those out. It will make things more flexible, more easy to use. Usage, of course, has not changed, although my configuration is now slightly more complex. My usage is exactly the same, and nothing changes. That's a lot of PHP code. Not all of us are fans of writing everything in PHP. I've spotted this. So if you're not so keen on PHP, then maybe YAML is more the sort of stuff you're interested in. YAML configuration also works. So Symfony's container is configured like this. We are doing exactly the same basic idea, but now we're doing it in configuration and not in PHP code. I have concept of parameters, and I've created my paper.size parameter, and I've called it A4. I've got my services, which is the key that Symfony's container uses for all of the Pimple closures, the analogy. The way Symfony's container works is you have to give it the class name. So here I'm saying I want an airmail paper. And I'm saying that airmail paper's constructor takes an argument. The argument it takes, please put in there paper.size. So with Symfony's container, I don't need to write the instantiation myself. It will deal with that for me. I merely have to tell it what class I need, which parameters that constructor takes, and it will do the rest for me. And of course, not only can I just assign parameters, I can assign other dependencies. So when I instantiate my letter, I say my class is of class letter, and I say the argument to that constructor is a piece of paper. And because it starts with an @ symbol, Symfony's container knows, I need to retrieve one of those. So I had better go and instantiate a paper before I go and instantiate a letter. So I've not written any PHP code, but behind the scenes, Symfony's container will instantiate me a piece of airmail paper, instantiate me a letter, and put the paper inside the letter for me. This is far more fun to write, far easier to write, far easier to debug, because there's a lot less code. It's Symfony, so we have absolutely massive use statements all the way across the page. This is one of the nice things about HD resolution screens. We can actually fit class names on them. We configure our container using a container builder. Then we retrieve a file locator, which we pass into a YAML file loader, which enables us to load services.yml, which we can then configure our container with to retrieve our letter. The absolute usage, letter equals container get letter, is basically the same. So as you can see, all dependency injection containers are configured differently, but their fundamental usage is identical. They all look very, very similar at the use case level. So it doesn't really matter which one you pick. So a couple of recommendations. Hold your configuration separately from your instantiation. You will thank yourself when your client changes their mind. That is what clients do. They do it a lot. Make your life easier when they do that. Create each object separately. It is quite tempting, particularly with the containers that require you to write factory functions, to instantiate all your dependencies immediately. That's quite a tempting thing to do because it is easier. And as I said, if it's easier, that is the way the software developer tends to go. Resist. Write separate factories, or however you're doing it, so that you can retrieve your dependencies independently of each other. So everything I've talked about so far has been very manual. You've had to manually choose what's going on. With some of the dependency injection containers, PHP-DI is one, ZenDI is another, you can do this automatically. And this is quite clever, so let's explore that slightly. Automatic resolution is made possible by the power of reflection. Has everyone heard of reflection? Has everyone been told never to use it? Yeah, it's not so fast. It's very, very powerful though, and it works really well for stuff like this. So here I've got my class. It hasn't changed barely at all since before, but you will notice that I've type hinted paper. So I've now said that paper must be some airmail paper. It's the only change I've made to this class. As a result of doing that, if I'm using ZenDI, when I do DI get letter, ZenDI will go, we need some airmail paper. That's a class. I can instantiate some airmail paper, and it will instantiate the airmail paper and put it into the letter for us. So we didn't even have to think about it. Because the system is clever enough. We have provided enough information as part of our code for the system to know what we mean. That's really nice. I like it when computers can do the boring work for me. And this is one of those cases. And if you actually var dump out letter, you will see that the airmail paper has got a resource ID, one less than the letter object. The container has automatically instantiated it for us. It worked it out by magic. Obviously, we still need to tell it about sizes. So it's not a magic bullet. It doesn't understand that I want A4 paper. It is not telepathic. So we have to tell it how to pass in the scalar properties into, the scalar parameters into the constructor. So we do that via set parameters. Here I'm telling the DI container that if you need an airmail paper, please set it to A4. And it's using reflection again, so I'm using size as my parameter, and the container will look for $size as its particular key within the function signature of the constructor. Usage, of course, has not changed. Sometimes you might not know the size you need until you want to retrieve the paper. So again, you can pass it in as a parameter directly into get. And it will configure the rest for us. Yeah, it's quite clever. I quite like this. Depending on a concrete class is not very clever for long-term maintenance of your source code. Again, it's quite tempting. But where I type hinted against airmail paper, it's much better to type hint against an interface. So we're going to type hint against paper interface. Paper interface will then define the methods that my letter needs in order to work. And I can now pick and choose which type of paper my letter works with. If I've used a concrete implementation as my type hint, I have lost a lot of flexibility. So again, do not do that. Always type hint to an interface. Code looks really, really similar. Nothing significant has changed. We still have airmail paper, we still have a size on it because we still need to instantiate the thing. But now we can add what's called a type preference and tell the DI container that if you see a paper interface, in this particular case, I mean airmail paper. Maybe in another case I'll mean writing paper. In this case I mean email paper. And again, the automatic DI container can go and do its magic. I used magic quite a lot in that section, didn't I? Automatic dependency injection containers use a lot of magic. It feels like magic. You type a little bit of configuration and a lot of things happen behind the scenes and the right answer comes out into your configured object. This is really cool when it works. When it doesn't work, magic is really hard to debug. Magic is a nightmare to debug. Magic is normally where all your maintenance problems come from. So be aware of this. If you're going to use an automatic dependency injection container, you are signing up to the source code doing stuff that you may not fully understand. Be aware of that and make your choice accordingly. I will note that most DI containers are not magic. Then Framework 2, for instance, started with a magic automatic container as its default, but when we shipped with a manually configured one. That wasn't a coincidence. We learnt during the beta. I'm glad we learnt during the beta and not when it went stable. So yes, automatic dependency injection containers have their place. You should understand why you are using them. If you don't understand why you're using them, use a manually configured one. You will thank yourself in 7 to 8 months' time. Maybe 9 months if you're lucky. So I've talked all about dependency injection container and how they work. You now have a good fundamental foundation in how the systems, dependency injection containers work. You are now fully conversant in all that. There's one term I haven't mentioned yet that comes up a lot when we're talking about DI, and that's ServiceLocation. So I need to talk a little bit about what ServiceLocation is, and we've already seen an example of this in Sean's talk. ServiceLocation is when you inject the locator into the class that has the dependencies. So what I've done here is I've constructed, in my letter, my constructor takes a locator, and then I retrieve the paper via my locator. This all looks quite clear. We still have dependency injection going on. I've injected my locator. We also have service location going on. My locator is retrieving the paper. So, service location. The key thing here is that the component is now pulling its dependency when it needs them. It is no longer having its dependencies pushed into it. They are being pulled. It is service locating them. It's still decoupling. We are not talking about a tightly coupled system. My letter is not tightly coupled to writing paper. It is tightly coupled to a service locator. There's 2 or 3 little problems here. The main one is hidden dependencies, for me at least. Once you have a service locator into your component, into your class, anyone who maintains that class can add a new retrieval from that container. They can introduce another dependency into your class. So my letter could now start pulling an envelope out to have a quick check of what's in there. When you've got a container in a class, you can pull everything out of that container. The problem is that you might not notice this is happening. And now you've introduced additional complexity in your class. You have now probably made your class do more things than it was doing before, because it's now got a method at the bottom of the class where you've pulled in a couple more things to make life easier. It's a magic bullet. Put your container into a class and suddenly your class responsibilities will grow. It's really hard to stop it. There are, however, genuine cases where having a container into the class is a perfectly valid design decision. What I'm suggesting is that if you do not understand why you are putting a locator into your class, then you probably shouldn't be doing it. Inject the actual dependencies that class needs. You will thank yourself later. Also, Also, when you introduce a locator into your class, you have now made testing that much harder. Instead of having to just mock my writing paper, I now need to mock a container that mocks some writing paper or something. Things start getting more complicated. Generally, this is unnecessary. Generally, we only do this because we made a mistake and thought our life would be easier. I will hold my hand up here. Zen Framework 2 does this in controllers. Our controllers automatically inject the service locator into them, so that when you're in your action, you can just pull out of the container anything you need to get your work done. I would argue we made a mistake doing that. Hopefully we'll fix it for Zen Framework 3. But I'm not the decision maker, so we'll see. So that's my views on dependency injection containers, service location, DI, etc. So to recap this, the things I want you to take away is that DI is all about loose coupling. That is the key feature. If you take away nothing else, it is separating up your code into smaller bits that you can recompose differently when you need to. You get the ability to separate the configuration of your objects from your construction of your objects. This can be quite powerful, particularly with different environments and things like this. So that flexibility can be quite beneficial. Dependency injection gives you this sort of flexibility. And it makes your testing much easier. I'm not going to ask you to raise your hands on who tests because I will get depressed. But when you come to testing, if you're not testing already, then it will become blindingly obvious why we inject our dependencies into our objects. So I've spoken for about 40 minutes, and what I'm going to leave you with is that this is really, really simple. The terms are quite patterny, they're quite enterprisey. Dependency injection, inversion of control, service location. These are quite Martin Fowler words, they're quite powerful words, there's lots of stuff written on it. In practice, it is really, really easy. There is no excuse not to be doing this stuff. I will finish now. Thank you very much.